prompt engineering, context engineering, loop engineering, and now graph engineering. That's 4 concepts in roughly about a year. And so what is graph engineering, and do you even need to know it? Spoiler alert, yes, it's something that you're gonna wanna make sure you know and understand. And in this video, I'm gonna show you 1, what graph engineering is, number 2, what the similarities are and the concept that carries across all of these concepts, and number 3, help you understand when you need to use each of these tools in their right context. So before getting into it, the AI Builders Plus community is built on this entire idea. Systems and not vocabulary or hype or features. So inside it, you have access to the AI content operating system, the video editor system, the Claude Code and Codex masterclasses, the agentic brain system, loop engineering. All of these are taught as a system you build rather than a feature or hype word that you learn. So the link's below if you want to learn more and dive in and start implementing these today. Otherwise, let's get back into it and learn graph engineering. So where we started was with chat, and this is where a lot of people start. This may even be where you're at today. When you interact with Claude or Codex or ChatGPT or whatever in the chat, and you're doing work, what it usually looks like is you write a prompt, AI answers with whatever that is, you check the answer or the output, you ask for a correction, AI tries again, and then as a human, you check again, right? It's the see, do, check kind of principle. So coming out of that, we learned, hey, there's probably a better way to write a prompt because chat was like really iterative. So maybe we need to prompt engineer. And this is when we got into prompt engineering, which was, hey, Claude, here's the goal and context and maybe the files that you need access to. Here's how it works. Like, here's how I want you to do this, and here's how to do this well. Don't do this. Here are some of my rules, and then come back with the result. And then this is where you verify, you observe, judge, and then you confirm when this is done. So at this point, you have to bring in all the context one-off every single time. So drop those in, drop those in, drop those in, and then check the result at the end. Now, to be honest, it works, but it just doesn't run without you sitting there or me sitting there. So all 3 boxes were there to check this off, see, do, verify. They just lived in a chat window, and all of that was me or you, right? So the same task now today. Let's look at loops. So now we got into loop engineering, which inside of loop engineering, instead of you handing absolutely everything and checking everything, you have a set of tasks. Now, inside that set of tasks, you would say, here's the maybe a trigger. All right, so we have kind of those components in here, right? When do we need to execute a task? What are the rules to do it? And then what does done look like and how do we check that? What started happening here though is we hand it to Claude Code, right? So Claude Code in this example, the trigger happens. Here's the task I need you to do. Maybe it's go check Reddit, go ahead and check Instagram, go ahead and check YouTube. And I have specific rules on what I want you to do. Go check Reddit for this topic, research this topic, research it on Instagram, research it on YouTube. Each of them has their own kind of unique quirks, right? But then I want to come back here and then check if this was all done. So do Reddit, check that it was done against my rules on the task, what done looks like. If it wasn't done, go ahead and start back over here and run the task again until it meets my standards of what good looks like. But then if you have multiple tasks for an agent, you might do the same thing with Instagram. Do this task in Instagram, research, synthesize it down, make sure this is done, and then come back over here if it's not done. And then you do the same thing with YouTube. The good news is Claude will perform the work and then check if it's done against your rules and then synthesize everything out and then give it back to me. But the problem is if you have a really big task, you run into context rot, right? Like it just doesn't have a big enough context window to run a bunch of different things. So loops are very strong in the sense that, like, if you have a specific task that has already your definitions in place, it's amazing. And if I break down what a loop really does at the end of the day, is it changes the jobs. Claude's job is now read the goal, inspect the files, edit code or write something, produce something, run a check, read the result, decide what to fix if something needs to happen, repeat until the goal is satisfied, and then report what changed. Then your job now is not like keep pushing Claude all the way to the end. Your job is to define the goal, the boundaries, the definition of success, the taste or judgment. If Claude gets stuck, then have it bring you back in. That way you insert any judgment needed there, and then just reviewing the final work. So Claude starts running without you. But the thing that we ran into with loops is that with loops, a single agent starts running out of context when you have all these jobs. If you have it trying to do Reddit, and then the next task is Instagram, and then the next task is YouTube, and the next task is read emails, and the next thing, and like it runs out of context room. So that's where we get into graph engineering. Now, graph engineering at its core, what I'm going to do, I'm going to go and move this away, is very much the same thing. This starts to look very similar to loop engineering, but the only difference is you're going to have an orchestrator typically that spins up an agent that each is assigned to its own task. So you have an agent that does the Reddit research. Maybe you want to do deep research, an agent that runs into the Instagram side, and then an agent that runs YouTube. And then based on that, it will complete the work that you asked it to do across each of these in parallel, each of them with their own independent review agent. Honestly, I recommend having a separate agent do the review rather than having the agent check its own work. But then based off of that, they are all separate tasks. So if they're really big, your quality goes up. You don't run out of context windows in each agent, so you avoid context rot, and your quality goes up. Now, if it doesn't meet it, it loops right here, it loops right here, and it loops right here. And then at the end, when all of these get synthesized, they're all completed, this comes right back to your original agent right here. And so this is, in essence, Ultracode, or dynamic workflows in Claude Code, is kind of designed to do this. This basically allows Claude to decide and make that decision for you. It eats up a lot of tokens, but it makes it a little bit simpler. Otherwise, if you have a loop and you have these defined, the only difference between a loop and a graph is that you are now breaking up the loop into different tasks with their own agents assigned to them. So the biggest takeaway I want you to have on this is graph engineering, loop engineering, and prompt engineering all share the same kind of body, right? You have a goal in the context. Here's how it works. Here's what done looks like. You have your rules baked in for what you want it to do and not do, and then how to verify it. So prompt engineering has its place in the world when you want to just, hey, fire off something really quick. I have like a one-off. Then you have loop engineering. This is, if I back up, prompt engineering, this is essentially the /goal command. That is a very good way to have Claude fire off. This is prompt engineering in its core. When you have a loop, this is, hey, Claude, here are the rules. Here is the job to be done. This is an ongoing process, and I want you to check, to verify, and kind of keep this going. And then it kind of runs. But if you have simple tasks that aren't super long running where you need a giant context window, this is where a loop is perfect. And this is probably going to be your daily driver in addition to prompt engineering goals. Loop engineering is generally good enough for people like you and I. However, if you have these large systems that now this thing keeps growing and growing and different jobs to be done, and you're running out of context window or running into rot in your loops, This is where graphs are really helpful because now you have a big system with multiple tasks with their own definitions of done, their own rules, their own review, their own work, and you have it run across the board, kind of fan out. This is when a graph is extremely powerful. So, do you need to know graph engineering? Absolutely. Do you need to use it every single time? Absolutely not. This is just another tool for you to have in your toolbox and use it at the right time. So prompt engineer, use a goal. Loop engineering, automate the tasks and let Claude run on its own. When you run out of context window usage and you're getting context rot, then it's time for a graph. So there you go. That's graph engineering at its core. And if you want to learn more, again, you can always join the school community. Drop me a comment here below. If you'd like to learn more, have questions, hit me up. Always happy to help. All right, cheers.